Good day, ladies and gentlemen. The topic for this presentation was burnout from a research work that was done in evaluating the barrier and enabler drivers that impact the innovation life cycle of startups in the food and beverage industry. The food and beverage industry plays an integral role in the production of sustainable food and drink products. The industry continues to evolve due to the ever-changing consumer requirements. This necessitates the demand for startups to support the larger firms. In the process of trying to innovate, startups face barriers that are complex and dynamic in nature. The work done by Gananakis C. 2016 broadly categorized the barriers that startups in the food and beverage industry face into economic and non-economic factors. It was also found that the growth of startups in the industry is directly linked to the diverse consumer trends for food and drink products, as noted by Mbonga Jet 2017. As noted from literature, the main problem facing startups in the industry is the high failure rate after commencement in the first 2 to 5 years of operation. And the specific problem facing startups in the industry, as noted by Bigliardi and Galati 2018, is the lack of effective innovation strategies by startup owners. The research problem is summarized in the model described in Figure 1 in terms of barriers to innovation as knowledge barriers. This is where startup owners lack the level of knowledge to innovate strategically. Organizational barrier. These are the challenges that are as a result of organizational structure, such as the resistance to change syndrome by employees towards innovation. Collaboration barrier. These are the challenges in developing a long-term business partner, such as finding a strategic supplier. Financial barrier, such as having inadequate access to financial facilities from financial institutions. The research aim was to seek to identify and thereafter draw up relationships among the identified barriers with the objective of optimizing management strategies in the innovation lifecycle process. The methodology used is a stepwise approach described in Figure 2. These are identification of themes from literature, grouping the themes into barrier and enabler drivers. Through a systematic literature review approach, the number of authored citations was noted, with percentage weight allocated to each driver. Together with the general 4 phases of an innovation life cycle and the developed weight, an innovation life cycle framework was developed. This will be described later. Due to the dynamic nature of the barrier and enabler drivers, a causal loop diagram and a stock and flow diagram tools were developed to describe the dynamic interrelationship among the identified drivers. The percentage weight per driver was calculated by determining the number of citations per driver from the total lot of citations as described in Formula 1. A total of 174 literature references analyzed resulted in 40 identifiable themes or drivers that impact an innovation life cycle of startups in the food and beverage industry. Table 1 shows the top 10 drivers with the drive for sustainable food production with regards to green production having the highest normalized weight score of 8.41%, followed by the rapid changes in market forces, and then the challenge that startups face in transforming prototype ideas into real-life sustainable ideas, which is followed by changes in consumer trend and lifestyles that are rapidly changing. Table 2 shows the normalized weighted score for the other 30 drivers. Figure 3 describes the innovation lifecycle framework for the research work. It combines the general 4 phases of an innovation lifecycle with the barrier and enabler drivers and their influences at a different stage. The phases described are opportunity phase, where ideas generation starts. The refine phase. This is where the best project idea is selected and incubated. The establish phase. This involves the project idea or product development. The decide phase. This involves the commercialization of the developed product. It also involves deciding on the continuation, sustainability, or decline of the innovation lifecycle, which depend on the market responsiveness or feedback. It should be noted that these phases are dynamic and have to be continuously adjusted in order to achieve optimized business performance. Figure 4 shows the percentage weight distribution influence of the 4 phases in comparison among each other. Phase 3 impacts the innovation life cycle the greatest at 44.62%, followed by Phase 4, then Phase 2, with Phase 1 the least at 24.77%. Vensim SD tool was used to map out the dynamic relationship among the barrier and enabler drivers to form the causal loop diagram as described in Figure 5. Figure 6 describes the stock and flow relationship among the 4 phases and the drivers that impact the innovation life cycle of startups in the food and beverage industry. In discussing the result, Phase 1 shows that consumer trend and lifestyle and niche markets, which are enabler drivers, impact this phase the highest. Phase 2. In this phase, market forces, niche markets, and technology capability are the enabler drivers with the greatest impact. Phase 3. This phase is the most critical phase because it has the barrier driver B13, the sustainable food production with respect to climate change. B13 at 8.41% has the greatest percentage weight of influence on the innovation life cycle, and therefore it is very critical. Phase 4. This phase follows Phase 3 in terms of criticality as a result of the influence of the barrier drivers with a total barrier influence of 17.76%, which is the second highest as shown in Figure 4. In conclusion, the barriers discussed in the research paper are also unique to startups in other industry, but the food and beverage industry was focused on because of its importance to sustainable food production. The research method of using extant literature to cite the number of times a driver was cited was chosen due to the constraint of sufficient quantitative data. The developed innovation lifecycle framework shown in Figure 3 that was developed for this research work is supported by the research work done by E.L., Bassiti and John R. 2013 and Meyer S.D. et al. 2016. Thank you, everyone.